Alright, we are doing a lesson on something called as a discriminant. I want to fill in this and I'm going to ask you guys if you recognize this. So the discriminant of any, so discriminant is for a quadratic equation, and the discriminant for any quadratic equation, standard quadratic equation, is b minus 4ac. Pause the video and see if you recognize what this b minus 4ac is. Okay, so if you think about your quadratic equation, quadratic formula to solve your the quadratic equation, it is negative b plus or minus b square. It's b square. I'm so sorry. B square minus 4ac over 2a. Yes, so you guys recognize this. So this b square, the value under the root, under the radical, is called as a discriminant. Why is that? Because depending on whether this, remember it's under the radical, so depending on whether this is positive or negative, we know whether it's real numbers or imaginary numbers. It can also be 0. If it is 0, that means this whole thing is gone. We have only one solution. And let me show you some examples for this. I'll show you some examples for this. So the value, again, one more time, the value of the discriminant is the one is up in the quadratic formula. It's the number under the radical, b square minus 4ac, and this will determine if my solution is real, if my solution is imaginary, or if I have only one solution. Alright, so let's go ahead and do this. So this is my first equation, x square minus 4x plus 2 equals to 0. So we're going to find it says find the value of the discriminant. My discriminant is going to be b square minus 4ac, so I'm going to go ahead and write this down here so I can do that for each one of them. So a is 1, b is negative 4, and c is 2, and therefore my discriminant will be negative 4 square minus 4ac, which is 16, minus 8, which is 8. Okay, this has got nothing to do with the solution. 8 has got nothing to do with the solution, but it tells you that because it is positive, because 8 is greater than 0, you have two real solutions. What kind of solutions are these? They are real, I know that for a fact, but it could be rational or irrational. For that I'll have to solve. Therefore, the number of x-intercept is going to be 2, because real solutions mean they hit the x-axis at 2 spots. So this is greater than 0, number of solutions is 2, and they are basically real solution. And the number of x-intercept is the same as this for real solutions. Therefore, it will be some numbers here and there. But let's go ahead and actually solve this equation to see if this is true. Is it true that I get two real solutions? So let's go ahead and solve this. So we're going to do that now. So maybe I'll use my quadratic formula. So if I use, because I already have my values of a, b, and c, so x equals to negative b, which is negative of negative 4, which is positive 4, plus or minus b square minus 4ac, which I already solved to be 8, over 2 times 1. Everybody good so far? Because I already solved for b square minus 4ac. That's this one. That is basically this one. This is my discriminant, which is b square minus 4ac, which is 8. And so instead of doing it again, I'm just writing it here. And let's go ahead and continue solving this. So 4 plus or minus square root of 8 can be written as 4 times 2, which is 2 square root of 2. All of you can simplify the radical at your own pace, but that's what it's going to be, divided by 2, which I can simplify each one of them. So this gets simplified to 2 plus or minus square root of 2. So I do have two solutions. How do I have two solutions? One solution is 2 plus square root of 2. The other solution is 2 minus square root of 2. You can leave it like this, or you can write it like that. Sorry, here we go. So you could see it. So yeah, this is my two solutions, solution 1, solution 2. But I said you can also leave it like that. So they are real solutions. 2 plus square root of 2, value of square root of 2 is approximately 1.4 something. So 2 plus 1, so it will hit the x-axis. That's why you have two, number of x-intercepts is 2, and they are real solutions, but in this case, they are irrational solutions. Remember, square root of 2 is an irrational number. It's a radical that cannot be simplified, doesn't have, so it's basically two solutions which are irrational. But that I can find out only when I do my solve it. But also another thing, square root of 8. Square root of 8 is an irrational. It's 2 square root of 2. That's another reason I can quickly even just look at this and say. So my one solution is 2 minus. So they're both actually on this side. They're both positive. So my parabola will look something like this. 2 plus and 2 minus. This is just approximation, just 2. So I think our main goal is to figure out that because the discriminant is positive, because it's greater than 0, I have 2 solutions, and those solutions are real solutions because there's no I involved. Yeah, that's our thing. Okay, let's keep going. Let's do the next one. I need to find the value of the discriminant. A equals to 1, B equals to -4, C equals to 3. I'm going to find my discriminant, which is B squared, -4 squared minus 4AC, which is 16 minus 12, which is 4. This is also greater than 0, therefore I have number of solutions is 2. And you know what? Because I have square root of 4 it's not irrational. Square root of 4 is a whole number. I do have real solutions, yes, because there's no imaginary number, there's no I here, but they will be rational. I can say that straight away without even solving, because square root of 4 equals to 2. So there won't be a square root of, unlike here where square root of 2 was 2, square root of 2 hits here, and number of x-intercepts is again 2. And I don't know what my solutions are, but I'm not solving it right now. Right now it is for us to understand it's 2. How do I know it's rational? Because square root of 4 is rational, it's not irrational. Therefore it's 2 real solutions, and I'm not sure where it's going to touch it. For that I'll have to solve, but I'm just drawing a rough sketch. Alright, let's keep going. So what I'm going to do is I'm going to hit pause, or rather you guys hit pause and go ahead and solve for the discriminant, do the third row and fourth row by yourself. And then you continue this video to check if your answers were correct. I will continue doing the work, and you can check if your work is correct. So what you notice here is you get the discriminant to be 0. If the discriminant is 0, that means you have only one solution. Because why? Because the whole b square minus 4ac is gone. So you're only left with negative b over 2a. There's no plus or minus. It's a plus or minus that gives us 2 solutions. Whereas if that plus or minus is 0, if it's not there, my solution is just negative b over 2a, whatever that may be. Right? So I have one real solution, which is basically 1, and number of x-intercepts is 1, and so this is what is called the repeated solution. I don't know what my solution is. Right now I'm not trying to solve, I'm so sorry, here we go. Right now I'm not trying to solve this, I just need to know what the solution is. So again, my discriminant value is 0. If the discriminant value is 0, I have one solution which is real, there's no I involved, so it's real. Number of x-intercept is the same as the solution, and this is what I get. Okay, let's go ahead and do the last one. I'm hoping that you've done this. I'm going to quickly show the work, and then you guys can compare if you got this right. Alright, if my discriminant is a negative number, right, so when I take the square root of that, it will be, here, let me go ahead and do this. Sorry, -4, because this is under the radical, this is nothing but 2i. So anytime you have a number under the radical that's negative, that means I have imaginary solutions. So 2, but they're both imaginary. And if it is imaginary, they are not real numbers. They're opposite of real numbers. That means they don't touch the x-axis. So they have none. And therefore it will look like my parabola will be above the x-axis. My parabola will be above the x-axis. Okay, so I hope we got this. I will post the next video, which will be for the next page.